Assalamu alaikum, sir. My name is Maruf Hossein. My ID is 1373. In our presentation, we are going to talk about first, follow, and partiality, which are concepts of compiler design. So normally the first cell set tells us which terminal can appear when a grammar symbol begins to produce a string. Before learning about first set, at first we have to understand about production rules. So normally a production rule contains three things. One is left hand side, then an arrow symbol, then a right hand side. In the left hand side, it contains non-terminals which are denoted using capital letters, and in the right hand side it contains both non-terminals and terminals, and terminals are denoted using small letters and symbols. So there are several rules to find out first set. One of them is the first of terminal is the terminal itself. That means for example, the first of small a is the small a itself. Similarly, the first of epsilon is the epsilon itself. Here we can see. So while finding out the first of non-terminals, there can appear several cases. Normally a non-terminal can have multiple production rules. Here you can see capital A, which is a non-terminal, has two production rules. One is small a, capital B, and capital C, and the other production rule is small c and small d. So while finding out the first set for non-terminals, we have to find out the first for each production rules. So for these production rules, if we want to find out first of a, then the first set will be small a and small c. Here small a comes from the first production rules and small c comes from the second production rules. Here is the another case. So normally a production rule, normally a non-terminal can have multiple non-terminals in the right hand side which are dependent. So at first we have to find out the non-terminal first set of non-terminals which has a terminal in its first set. For example, for these production rules, if we want to find out the first set of non-terminal S, and we see capital A, capital B, capital C, capital D, which all are non-terminals. So at first we have to find out first set of capital A, which is small a and epsilon, and then the first set for capital B, which is small b and epsilon, and the first set for C is just small c, and the first set for D, I mean capital D, is small d and epsilon. Similarly, for E it is small e and epsilon. So after finding out these non-terminals, then we have to move to the S, and while finding out the first set, we can see the first non-terminal is A, and we already see that an A has two first symbol, which one is small a and epsilon. So when a first set contains epsilon, then it moves to the next symbol. For this case, which is B, and the first set of B is B and epsilon, which also contains epsilon. That means we have to move to the next symbol, for which is C. And in this case, we see the first of C is only C, and it does not contains epsilon. That means here we have to stop. So finally, we get the first set for non-terminal S is small a, small b, and small c. Thus, we can find out the first set for any non-terminals. For further discussion, I'd like to invite Shimanto.
Assalamu alaikum. My name is Mohammad Shahidul Haq, and last four digit of my ID is 1404. So in this part of this presentation, I will be explaining the follow function, which is a very important concept in compiler design. Let's start with a basic idea. The follow function is a set of non-terminal that tells us which terminal symbols can appear immediately after that non-terminal in some valid string of a grammar. In simple words, follow helps us to understand what can come next after a particular non-terminal. This information is especially important when we build a predictive parsers like LL1 parsers. So here you can see in the screen, there are some production rules and the first function of the production rule. If we want to derive follow function of the production rule, we have to consider three rules to derive follow from that. What are the rules? Rules number one: if a terminal appears right after a non-terminal in a production, the terminal is added to the follow set directly. Rule number two: if an allowable non-terminal appears after our target, then we also include the first set of that symbol except for the epsilon. Rule number three: if a non-terminal appears at the end of the production, then the follows set of the left-hand side that must add to it. Let me show an example here. We are trying to derive the follow function of this production rule from here. So basically, where we start, actually, there we put a dollar sign. So at the first row, E tends to T E prime. Here we are starting our follow objective. So we put a dollar sign here, and E is appearing at the last production rules here, and E is followed by the closing bracket. So closing bracket is a non-terminal, and so that following the rule number one of follow function, we are putting it to the follow of E directly because it is a terminal. And if we're talking about the follow of T here, we can see that T is followed by E prime, and E prime can generate plus E prime, and E prime is a non-terminal. So there are two rules where exist non-terminal. If it is non-terminal, then the follow of the function T will be the first of that non-terminal. So the first of that non-terminal is plus and epsilon in the second row, you can see. But the third rule says to us that there is no existence of epsilon in follow function, so we will remove it. So at first, for the follow of T in third row, we will put the first of E prime, that is plus. Here we are putting plus here, and then it appears as epsilon, so we will not accept epsilon. Then we will forward our movement to the follow of E prime. The follow of E prime, here we can see that is nothing but a dollar sign and the closing bracket. So we will directly put down here. So finally, the follow function of T will be the plus dollar sign and the closing of the closing bracket. Another example we can see here. In previous slide, we have seen a derivation of follow function if the production of if tends to id or starting and E then closing bracket. So what is the follow function f will be? We have seen already in the previous slide, but I am telling it to you to understand precisely. So what will be the follow function of f? If we want to derive the follow function of f, we have to look where f is appearing at the right side of the production role. In here we can see f is appearing in third row where T tends to f T prime, and fourth row T prime tends to star f and T prime or epsilon. So in this case, we will pick the third row at first because it is working sequentially. So for the third row, f is followed by T prime. So here T prime is the non-terminal. The rule number 2 tells us that if it is non-terminal, the followed function is, if it is non-terminal, we will put the first of that non-terminal as the follow of the function we want to derive. So the first of T prime is star and epsilon. So for the last production rules f, we are putting star at first. We are not putting epsilon because we are not accepting epsilon in follow function. So in this case, we are not putting epsilon, and because of not putting epsilon here, we will move forward to the follow of that non-terminal. So the follow of non-terminal T is plus dollar symbol and the closing bracket. So for the follow of f, there we will write down the star, plus, and dollar sign, and also the closing bracket. In this slide, we can see the the complete overview how each non-terminal behaves in this grammar, and it will be very useful when constructing the parsing table later in the presentation. Actually, that concludes my explanation of the follow function. Thank you. Now I would like to invite my next teammate, Ismail.
Assalamualaikum, sir. Myself Ismail Hussain and my ID is 1001. Uh, First of all, we need to know that what is parser. A parser is a program that takes an input string and an underlying grammar and they generate a parser tree for that string. If if the string can be derived from the grammar, the parser is successful. Look at the example on the screen. We have to input string id equal id plus id into id and a set of a grammar rules. The job of the parser is analyze the input and verify its structure against the grammar, producing a parser tree which visually represent the static structure of the input. Maruf, next slide, please. In next slide, we can see that there are two main strategies to building a parsing tree. One is top down, and another was a bottom up parsing. In top down parsing approach, we can say that in the top down approach, we start for the start symbol like s in our example and try to explain its downward to match the input string. The key decision here is which producing to use. We are perform a leftmost derivation, and right side we can see the bottom up approach. In the bottom up approach, we start from the input symbol and try to reduce the upwards in the start symbol. The key decision here is when to reduce. We are essentially reconstruction the reverse and the rightmost derivation. Next slide, please. In the last slide, we can see the classification of the parsers, and also the parsers are the essential component. They bridge the gap between raw input code and its structure understood by the compiler. We achieve this using powerful top-down and bottom-up technique. With the LR family of parsing standing out as the gold standard for robust language processing. Uh, that's all for me. Thank you, everyone. Thank you.